Hello, this is Brandon Clayton, the Algebra Guy, and today's lesson is quadratic functions in vertex form. What is vertex form and why is it important? So by the end of this video, you'll be able to do the following. This is TEAC 6b, write equations of quadratic functions given the vertex and another point on the graph. Write the equation in vertex form. This is vertex form here, and rewrite the equation from vertex form to standard form. So you need to be able to go from vertex form to standard form, and we're going to look at some star problems that do just that. So let's jump right into the star question. So instead of giving some background, we've had enough background on quadratic standard form and getting it to vertex form, but what does it look like in the star test so we know how to handle it? So here's a question that came from, last year's test. This is the last test that was taken. Which function is equivalent to y equals 3 quantity x plus 2 squared plus 7? So I will pause it here and see if you can work that. How would you handle this one? Now, the easiest way to work this, I don't know if it's the easiest, but one of the ways you can work this is simply put it in your calculator. You know, I've said before, whenever it says equivalent, most times you can put the equations in your calculator. You can put this in your calculator and then check these others to see which one is exactly the same graph. For the most part, I'm not going to do that because that's pretty simple and straightforward. We've done that before. We've shown equivalencies, and so I know you can do that. What I want to know that you can do is what this TEAC was mentioning earlier, which is go from standard form or vertex form to standard form, which is ax squared plus bx plus c. So let me show you how we're going to do that, and this one doesn't take long either. So if we're given this form right here, remember, actually we don't have to go there yet. So let's go ahead and work this out. We're going to do our parentheses first and the exponent. So x plus 2 squared is the same thing as saying, we're going to say 3 times this whole thing. It's the same thing as saying x squared. And our last term is squared, which is 4. And these two are multiplied together, 2 times x and times 2, which is 4x. So that's one way to easy way to remember how to 2 square perfect squares. It's to square the first term, square the last term, and then multiply these two together times 2. All right, so now that I have this, I can distribute this 3, giving me 12x, 12, and now I can take it out of the parentheses and add 7 to it. These two will add together, 12 and 17, giving me 3x squared plus 12x plus 19. And I hope this answers here, and there it is. So that's not too bad. Once you, and if you didn't know how to, that rule I just showed you, you can just use the box method even to multiply these two out. You can do x plus 2 and x plus 2, and then multiply it this way. You're going to come up with the same thing. So you can see you're going to get 4x here, and then you got x squared plus 4. So same thing, no big problem there. All right, so we're given a different problem. This time we have a leading -4 as a coefficient, but we're going to handle it the same way. So I'm going to have -4, and I'm going to multiply everything inside first, x plus 7 times x plus 7, which is the same thing as saying this first term squared, the last term is squared, and these both multiply together. 7 times x is 7x times 2, which is 14x. And that's positive, and we got -6. Now I'm going to distribute this -4 to all these terms on the inside, and that gives me -4x squared minus, what is that, 56x, and minus 196. And now I have -6 on the end. So when I combine my like terms, I get -4x squared minus 56x, and this is minus 202, and we're done. Which one looks like this one right there? Pretty easy, right? Again, you can double check your answers by simply putting this in the calculator, putting that in the calculator, and seeing if they come out the same. Now, if you just completely lost, again, you can put this in the calculator and put each one in there until you find an equivalent graph. All right, which quadratic function in vertex form can be represented by the graph that has a vertex at 3, -7, and passes through 0.1, -10? Now, here's a pretty easy problem if you understand vertex form. So let me write out y equals ax minus h plus k. So this is vertex form. in vertex form, the reason it's called vertex form is because we're able to quickly identify a vertex in this form. Kind of like when we have slope-intercept form, going back to a line here, we're able to identify our slope and y-intercept. Well, this actually helps us identify a vertex really quickly. Matter of fact, our vertex is going to be equal to, negative whatever your h is and whatever your k is. So if we have a 3, we know in here we should have a negative 3, because this one's positive is going to be negative our h, and then plus whatever k, so minus 7. So it's going to stay, the sign's not going to change. So I'm looking for one that has a minus 3. That doesn't, this does, and this does. And I'm looking for one that has a negative 7. And so these can't be it, and this one can't be it. So I already know it's going to be this one, just from understanding what the vertex rule says. So I can quickly identify where the vertex is. And just to remind you, vertex is, let's see how this is opening. Vertex is like this. So this highest point, man, that's a terrible parabola. Let me actually, I may be able to get, let's see, we move this to the right 1 2 3 and down 7, so it may be like that, right? So it's this highest point or lowest point on a parabola. So we know we're going to have one at negative 3, or let's see here, a 3 negative 7, so 3 negative 7, so right there. So that's pretty simple. Now another way you could have checked it is you could have plugged in, or you could have graphed these and check the point for 1 and see which one gives you 10. And that takes a little bit more time, because you have to graph each one and change it and plug in 1 to see which one's going to give you a negative 10, and that's one way to do it. But it's easy if you understand vertex form, like I just mentioned there. And that really does it. That's it for vertex form. So did we take care of everything? Yes, they really wanted us to know how to rewrite the equation, and we rewrote it from vertex form to standard form. And if we wanted to, we could have complemented by using the graphing calculator, but it's really not necessary. However, it is there as a great tool to supplement your answers. Thank you guys for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.